Hi there again. Well, we're coming down to the end of our C programming set of videos, and now we are going to take a look at the standard library. There's quite a few things in the standard library that we need to cover, and we're going to go through all the functionality that's stored in there of the major function calls of the standard library. We won't go into every tiny little thing because you probably won't have to deal with all that. But I want you to see most of it so that when you start reading some C programs and see what's out there, you can recognize the standard library and what the original programmer's doing in the code. The first section that we're going to take a look at is the standard input and output, and that includes file operations. And most of the standard library is in standard.io.h for input and output, and that's the file operations. We'll see that. We'll take a look at formatted output and input. We'll look at the character-based input and output, direct input and output, straight to the file system or to a device, file positioning, error functions, quite a few things. We'll also see character class tests, string functions, math functions, some variable argument lists, which we really already looked at that in the previous chapter, but we'll just kind of briefly cover it again. Some date and time functions that are good for timing and things like that, and a few things about how to find out just how limited your library is. And by limits, I mean how big or small, negative, can various numbers be. That's in limits.h and float.h. But right now, let's take a look at input and output with standard I.O. We've already seen a lot of these calls, these file calls and functions that are in there. But like I said, I want to go through them quickly again so that you can get a good handle on them. Get it a file handle. Anyway, small humor there. We're going to jump right in. Now, when we see a mode in an fopen and a couple of the other file handlers, this is file handling functions. This is what we're talking about. It will be, mode will be a string down here that contains one or more of these combinations of characters here. It'll be an R if you're going to open a file for read only, a W, which means write, of course. But what that also means to do is to open the file and pitch out everything that's already there. So be careful with a W. If you open a file and there's something good in it, your file pointer is going to be set at the beginning of the file, and everything beyond it is truncated. And that's generally a bad thing. So watch that. A is for append. It will open an existing file or create a new one and set you at the end of the file and ready to write to append to the file. Read and update is allowing you to read and write the file, to make changes within the file. Not only just append to the end of the file, but to change things in the middle of the file. Write and update is pretty much the same thing, gives you read and write capability with update. And append and update sets you at the end of the file and prepares you to update the file in A+. Now, if you put a B after any of those, that means do it in binary. So RB would be binary mode. If there's carriage returns and line feeds or other things like that, they will not be looked at. They will not be processed. Okay? Which means that you may want to open most of your files in binary mode, especially if you try to mix data between a Unix system and a Windows system that treat carriage return line feeds differently. Or if you're reading or writing, of course, graphic files and things like that, you definitely want to open those in binary mode so that you don't get some strange buffering going on. There's a sample fopen down there. File pointer equals fopen. So we see that fopen will return a pointer to a file. You put in the file name and then the mode, which is a pointer to a string of these characters. And you could put them right in there. You could put a double quotes and then an R plus B, something like that, for read and update binary, and then another double quotes. And then that would give you, as we know, the pointer to a static string. Note that there are double backslants in here, which is how you get a single backslant put into the file name, because otherwise it will take that as a switch, try to take it as a tab, escape character, and we don't want that. So you put double backslants to get a single backslant. That's fopen, what you have to do first, of course, to get any file open. Here's freopen, and this is used to reopen an existing file stream or file object. When you use freopen, it returns a file pointer to the new file pointer, and here you give it the file name, the mode, just like in the previous screen, and you have a new parameter. This is the old file pointer. Like out here, So we had fp equals fopen before. Well, now we want to reopen that same handle with a different file name. Normally what you do here is you pass in standard out, or standard in, standard out, or standard error as this old file pointer, and then that allows you to do redirection within your program, just like you would from the command line. So you can change the standard in to a file that you know is out there, or change the standard out to a file, and then just do a bunch of printfs. And the printfs will naturally go to the standard out, but you've already freopened it to another file name. So that's a common use of freopen. Flush will write buffered output to the device. So if you have fopened a file and you've been putting and getting and doing things to the file, that might be buffered in memory and not written to the device yet. You always need to do an flush. You want to do an flush before you close it. That way you have control and you know that the buffered output has been written to the device before you do the close. Here, I want to note that it must be called between read and write operations when you're doing an update on a file, because you're using that same buffer for reading and writing. So if you've written things out there, do an flush first. You must anyway, or you'll get an error, to clear the buffer, the file buffer. Then you can read data back into that file buffer and do other processing with the file. So an flush, and an flush with null as its file pointer, with no file pointer basically, flushes all of your open output files. So you can have multiple open output files to write to 2 or 3 many files at once, however many you like, and an flush null will make sure they're all cleared. Good thing to do right before you leave a program.